We are looking at the Chapter 6 review worksheet. This is pages 89 through 91 in your yellow book. This covers all the material through Chapter 6, and we're looking through sections 1 through 6. So we start with the first one. We need to solve a proportion. If I have 8 over 14 equals x over 35, first thing I want to look for is, can I reduce any of these fractions? 8 over 14 I can reduce to 4 over 7. That's equal to x over 35. Now I can do the cross product. 4 times 35 equals 7x. 4 times 35 is 140 equals 7x. If I divide 140 by 7, I get x to be 20. My answer would be D. Number 2, solving a proportion again. 3/5 I cannot reduce. I am not going to reduce 10 over 45 because that's not a reducible values. So I just have to do cross product. 3 times 45 equals 5 times the quantity x plus 10. 3 times 45 is 135. I get 5x plus 50 on the right. If I subtract 50 from both sides, I have 85 equals 5x. Divide by 5 to 85, and I get 17. So my answer would be B. Number 3, I have the measures of the angles of a triangle on the ratio of 9, 13, 14. I need to find the largest angle of the triangle. So if I just sketch this triangle, I have 9, 13, and 14. That's not the actual values, that's the ratio of them. So why don't I put an x on these, 9x, 13x, and 14x, because I know that the sum of these angles, since it is in the interior angles of a triangle, their sum is 180. So I combine those. I get 36x equals 180. Divide 180 by 36, and I get 5. And now I can plug that in and find each angle. So I have 9 times 5, 13 times 5, and 14 times 5. Well, 9 times 5 is 45. 13 times 5 is 65, and 14 times 5 is 70. They wanted the largest angle, therefore 70 would be our answer. Make sure you don't stop at x equals 5 there. They want the largest angle. You have to make sure we answer the question. Number 4, the negative of a photo is 5 centimeters by 15 centimeters. The actual photo has a longer side of 45 centimeters. They want to know how long the shorter side will be after the enlargement. So I have 5 to 15, x to 45. So I'm going to write 5 over x equals 15 over 45. It's a basic proportion. I can do cross product here, or I can look to reduce first. 15 over 45 does reduce to be 1 over 3 by dividing by 15. From here I can do cross product. I get x equals 15. We can also think of it as this one got 3 times bigger. The 15 went to 45, so that was 3 times bigger. Therefore the 5 was 3 times bigger. It went to 15. Number 5, they want to know what, if I take my proportion and I do cross product, what do I get 7x is equal to? Well, we can do that. 7x is equal to 2 times 14. 2 times 14 is 28, so 7x is 28. We go with D. On to number 6. Number 6, they want to know what side we need to complete our proportion. So I have KQ to KL. Then what side to KM? Well, the top side comes from the big triangle, KLM. The small sides, or the bottom values, come from the small triangle, KQP. I can also see that KL and KQ, which are my two values in the first one, are the first and second letters of the name of the triangles. So KM, being the first and third, its corresponding is going to be KP, which is the entire thing out here. So KP would be its corresponding. Always use those letters. They're good backup that helps you find the corresponding parts. Number 7, which proportion is accurate for the diagram shown? So in each of the answers, I notice I have D and H. D to H is the ratio. So I'm almost going small triangle to big triangle, because each has DH, small to big. So I want to find the ratio on this side of small to big. Well, the small side is C, and the big side is C plus K, which is the whole thing. Well, looks like C is the answer that fits. D over H equals C over C plus K. Number 8, the boy has an 8-foot shadow, or the 6-foot boy has a 4-foot shadow. At the same time of day, the tree has a shadow of 24. We need the height of the tree. So I could do 4 over 24 equals 6 over x. I went the shadow first, then the height. 4 over 24 reduces to 1 over 6 equals 6 over x. By cross product, I get 36 for my answer, which is D. Number 9. I'm going to do cross product, but before I do that, I'm going to see if I can reduce 3 and 91. I know I can divide 3 by 3, but 91, well, I know I can divide 90 by 3, so 91, well, that's probably not going to work. 6 and 13, that's not going to work either, but it's always good to check. It makes numbers smaller. So we do have to do cross product, so 3 times x, or 3x times 13, equals 91 times 6. This becomes 39x equals 91 times 6 would be 546. So I need to divide 546 by 39, and I get that x is 14. For number 10, we're going to do cross product again. 3 times 4x minus 11 equals 2 times 5x plus 1. We get 12x minus 33 equals 10x plus 2. I'm going to subtract 10x to both sides. Leaves me with 2x on this side. I'm going to add 33. That gives me 2x equals 35. Once I divide by 2, I get x is 17.5. Number 11, I need to find the geometric mean for 2 and 8. When we look for a geometric mean, we take the product of the two numbers and then the square root. So multiply, then square root. 2 times 8, we're lucky, is 16, which is a perfect square, so the geometric mean is 4. On number 12, we need to find the geometric mean of 4 and 6. Same idea, square root, multiply the two. Well, 4 times 6 is 24, not a perfect square. So we need to look at the factors. I can break 4 up into 2 times 2, 6 up into 2 times 3. I can group these 2's together. They come outside the radical. I'm left with 6 on the inside, or 2 times 3. So my answer for the geometric mean is 2 radical 6. Now we look at number 13. In 13, we are told that our two triangles are similar. First time looking at similar triangles, we know similar triangles have the same angles, corresponding angles are congruent, and corresponding sides are proportional. So, I have ABC similar to GJL. I need to first find B. To find that one, I need to find what's corresponding to B. Well, if I look at the name, J is corresponding to B. So these two would be the same. That means the measure of angle B is 100 degrees. I need to find angle L. Angle L is corresponding to C. I don't know C yet, but I know I have 25 and 100 here. So these two are 125. If I subtract that from 180, I get 55. So L is going to be 55 degrees. Last, I need the scale factor of the small triangle to the larger. So we're going to go small to large. And we need to find two sides that are corresponding. Well, 14 is in the small triangle, but its corresponding value we don't know. 18 is in the small triangle. Its corresponding value is 22. So 18 to 22, we can reduce that, maybe divide them both by 2. We get 9 over 11. So our scale factor here would be 9 over 11. 14, we have two similar polygons. We need to find angle A first. A matches up with W. They're both the first letters. So W is 85, so A is also 85. Then we need angle P. Angle P is the second letter, so that matches up with the second letter B. So B is 120, that means P is also 120. Again, corresponding angles are congruent. From 15 through 19, we need to complete the statement of similarity and state how they are similar, if they are. We have three options. We have side, 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 and angle, angle. So, I look at 15. I have a side length for the small triangle, side length for the large triangle, side length, and side length. So I have two sets of sides. I don't have TZ, so probably not going to look at side, side, side. I know this angle is congruent in both, but I don't really have another angle, so I'm probably looking side, angle, side. So they tell me TLZ is my first triangle. That's the small triangle. I'm going to put that value on top. So 9 for TLZ, or TL, goes to the whole thing on this side, which is 15. 18 for LZ goes to the whole thing on the bottom, which would be 30. So I know L matches, so I just have to make sure that this proportion is true. If it is, I do have side, angle, side. Well, 9 over 15 I can divide by 3, I get 3/5. 18 over 30 I can divide by 6, and I get 3/5. They match, they're true. 3/5 would be my scale factor. So I know that it works by side, angle, side, and TLZ is similar to CLH. Okay, next one we have URE. So I have 42 degrees here. Since this is vertical, I know this is also 42 degrees. And from the looks of this, I'm going to look for angle, angle. I know no sides, so angle, angle is going to be my best bet. If I could find this third angle and this third angle, I can see if I have two sets that match. Really, I already have the 42s, it's just needing that third one. So 88 plus 42 is 130. That means if I subtract 130 from 180, I have 50. That's angle R. Well, that doesn't match the 70. So we might have a problem here. Let's look at here. 42 and 70 gives us 112. 180 minus 112 gives us 68. No, that doesn't match. We don't have two sets. We only have one. So, not similar. I'm not going to state the triangle that it's similar to. And I'm not going to state how they are similar, because they just don't work. Okay, 17, we have RQS. We're trying to find the one that's similar to. I have vertical angles, so we'll take that pair. And then I have these arrows telling me I have parallel lines. When I have parallel lines, look for alternate interior angles. That'd be R and U, or Q and T. So we really have three sets of angles that work. We're not going to call it angle, angle, angle. Two of them are good enough. RQS, we go from 2, 3, 1 on the markings. So the corresponding one is UTS. So UTS is similar to RQS by angle, angle. Okay, we're on to 18 and 19, same process. So I have 22 for this angle. I know it's isosceles, so let's find those other angles first. 180 minus 22 gives me 158. So I know these two angles have to add up to 158. Because it's isosceles, I know these angles are the same. That's our base angles theorem. Half of 158 is 79. So these are both 79. If I come look at my smaller triangle, I have 79 here. Base angle theorem works again. That's also 79. That's good enough. I have two pairs, two sets of angles that are congruent. So I can call this one angle angle and say JFB is similar to VMZ. Number 19. I look at this one, I have three sets of sides. I'm looking for side, side, side. So if this is working, it's side, side, side. KGN is here, I'm going to match it up. So if I start looking at corresponding parts, well, this 15 is the long side, so I'm going to put 15 over 20, long side and the other one. Take the bottom side, 9 over 12, and then 6 and 8 is left. 15 over 20 reduces to 3/4. 9 over 12 reduces to 3/4. 6 over 8 reduces to 3/4. They all reduce to the same value, which we call the scale factor. So these are similar by side, side, side. We'll say KGN is similar to HLA. Okay, on to number 20. We need to find our variables. First off, if we look at these two triangles, they are similar by angle, angle. So let's match up our parts. I have 4 over x, 6 over 18, and 5 over y. Before I go further, I'm going to reduce this 6 over 18, and that becomes 1/3, because now I can take that 1/3 and I can solve this proportion, and then I can solve the other proportion for y, and it gives me a little easier values to work with. So if we look at this one, x equals 3 times 4, so x equals 12. And if we look at the second one, I have y times 1 equals 3 times 5, or y equals 15. For number 21, well, we have a couple ways we can do this. We can use our triangle proportionality theorem and say y over 9 equals 36 over 12. We have that because we have the parallel lines, meaning we can break these sides up to be proportional. Well, 36 over 12 reduces to be 3 over 1, because I can divide both those by 12. By doing cross product, I have y equals 9 times 3, or y is 27. To find x, I'm going to think of two triangles. I have my small triangle, I have my big triangle. So the bottom sides, if the small triangle's 18, the big triangle's x, then the right side of the small triangle is 36, and the whole thing is 48. So the right side of the big triangle would be 48. 18 to x, 36 to 48. 18 over x, or I can take 36 over 48 and reduce that to 3/4 by dividing both by 12. So then I have 18 times 4 equals 3 times x. 72 equals 3x, so x is 24. On 22, we're going to do the triangle proportionality theorem again. I have 15 over 5 equals 27 over x. I can reduce 15 over 5 to 3 over 1 equals 27 over x. So I get 3x equals 27 by doing cross product, which I divide by 3, and x is 9. For 23, I'm going to do 7 over x, so small triangle to big triangle. Then right or left side would be 5 of the small triangle and 15 of the big triangle. So 7 over x, 5 over 15. I can reduce 5 over 15 to be 1/3. So when I do cross product, I get x equals 3 times 7, or 21. For 24, I have this whole thing is 12. That's 3, that's the bottom part, so this part's going to be 9. So why don't I go small piece to whole thing, small triangle to big triangle. Now we could also do triangle proportionality and call this last part, this bottom part, 8 minus x. You know what, let's do that. So let's say x over 8 minus x equals 9 over 3. I can reduce, it makes things nicer. x over 8, or x over x minus 8 equals 3 over 1. Now when I do cross product, I get 3 times 8 minus x equals x. 24 minus 3x equals x. Add 3x to both sides. 24 equals 4x, so x is 6. Solved it a little bit different way. Maybe you say x over 8 equals 9 over 12. You would still get to 6 as well. We'll write that one. X over 8 equals 9 over 12. And that's doing small triangle to big triangle. Okay, finish up with our last few here. We have number 25. I'm going to write 8 over 6 equals x minus 4 over 9. Could also have written it as 8 over x minus 4 equals 6 over 9. That would also work out for us. Key thing there is the 8 and 9 are diagonal to each other, and the 6 and x minus 4 are diagonal to each other because those need to be our cross product. I multiply 8 times 9, I get 72 equals 6 times x minus 4. 72 equals 6x minus 24. If I add 24 over, I get 96 equals 6x. 96 divided by 6 gives us 16. 26, we'll do the same way. 21 over 14 equals x plus 8 over x. I can reduce. 21 over 14 becomes 3 over 2 when I divide by 7. And as you saw with the last, we don't necessarily have to reduce. I could have reduced 6 over 8 here, but I didn't. It's fine. We can still get the answer. Do cross product, I get 3x equals 2 times x plus 8. 3x equals 2x plus 16. Subtract 2x, I have x equals 16. Okay, on this last one, I'm going to make a ratio of the sides, 9 over 12. Then a ratio of the segments, x over 8. If I reduce 9 over 12, it becomes 3 over 4 equals x over 8. From here I can do cross product. 3 times 8 is 24 equals 4x. Divide both sides by 4 and x equals 6. For our last problem, we're going to do the same idea, but let's write this part as 20 minus x for this top segment. So now I take 18 over 14 equals 20 minus x over x. I reduce 18 over 14 and I get 9 over 7 equals 20 minus x over x. Do cross product, 7 times 20 minus x equals 9x. 140 minus 7x equals 9x. I add our 7x to both sides, and we get 140 equals 16x. And last step is we have to divide 140 by 16. And we get that it is 8.75. Okay, so that's our last problem. I hope that helped. That was quite a journey on this review. Hopefully those helped you. If you need more help, go back through them or try them on your own. And I hope you do well on your test.